Hello, my name is Francesca, a PhD student in Hazelab. In this virtual tour, I will be guiding you through our labs here at Imperial College London. I will tell you a bit about the experimental work that is done in the lab and show you some of the equipment. Let's go! Here we are in the Mechanical Engineering Department building where the Hazelab office and labs reside. At Hazelab, we carry out both computational and experimental research. Our group studies many areas of fire safety, from building fires to wildland fires. We cover both flaming and smoldering type of combustion. We investigate the phenomenon involved in these fires by conducting experiments and use computational models to simulate the phenomenon. Finally, the models can be upscaled to the real scale to learn what would happen in a real-life event. Now, follow me to the labs. This is where our lab is located. This section of the building, the Whitelow Laboratories, are named after Professor Jim Whitelow, who is a pioneer of laser-based flow instrumentation, which is frequently used in the research of fluid mechanics, heat transfer and combustion. Let's check inside. In here, there are many lab cubicles owned by different research groups in the thermofluids division. Equipment used in these labs include laser instrumentation, and we have a supply of different gases and chemicals. That is why we take safety very seriously, and students are only allowed to enter the labs after undertaking a safety course and after completing an induction with our technician Effie. Now we have arrived in front of the Hazelab cubicle. We have 4 students currently working in the lab on a range of topics. Due to the pandemic restriction, only 1 student is allowed to work in the lab at one time. Before we go inside the lab and check who's there, let me show you the views that we have from our windows on the rest of the campus, on the faculty building and on the civil engineering building. So let's go inside and see who's there. Oh, look who's there. Hello, Dewey. Hi. So on the screen you can see Dewey's experiments running. Dewey investigates and assists the remote sensing of wildfire in a peatland, which has both flaming and smoldering type of combustion. While flaming has been successfully detected using remote sensing, such as using satellites, smoldering detection remains a scientific challenge due to their behavior of having lower temperature and subsurface spread. The experiment mainly uses IR camera in a range of wavelengths to detect the fire. This camera is combined with optical filters to obtain a narrow wavelength radiation from the fire and see how the fire radiates in different wavelength bands. This experiment is conducted on smoldering peat and on pine needles, as you can see. Okay, so let's move on to the next one. In this experiment, smoldering in Arctic wildfires is investigated by using the experimental low-temperature smoldering apparatus, also known as ELSA. The freezing box uses a vortex tube to pump cold air into the compartment and enables the experimental study of smoldering in low-temperature condition. Measurement devices include thermocouples and a mass balance. The effect of cold soil temperature on smoldering dynamics is explored by controlling 3 parameters: the ambient air temperature, the temperature of the bottom boundary of the reactor, and the soil temperature. This lab-scale experimental rig allows us to investigate the the fire dynamics and emissions of smoldering peat fires. Emissions from smoldering wildfires are the dominant source of haze episodes. Emissions from smoldering can be as much as 3 times higher than those of flaming fires. There are 6 types of diagnostics set up in this rig. A mass balance is used to record the real-time mass loss in the burning process. Thermocouples are used to get the temperature profiles of the smoldering, whilst the GoPro and the FIR camera are installed to record the visual and infrared signature of the experiments. Nearly 20 species of emission gases are measured by FTIR. The particle emissions are collected by using PM cascade impactor. Apart from these 3 currently active experiments, we also do experiments on smoldering fire suppression, transition to smoldering, and firebrands, which is the main cause of wildfires urban interface fires. I'm just showing you here some samples that are due to be burned soon. So this is it, this is our lab. Now let's go upstairs to see our office. So here we are in our office, room 609. In pre-COVID times, there used to be 15 of us working in this office. Right now it's usually 1 or 2 people. So I hope you enjoyed the tour. Bye bye. Hope to see you another time.